Complement Cube is an Arduino-based device that responds to environmental sounds by applying color theory principles to produce a visual experience. It's intended to be left running in the background where it listens and responds by producing animated, constantly changing patterns from colors that are selected by applying simple, well-known principles of color harmony. First, we start with the color wheel. Colors are defined by their location in degrees, with red being 0, and its complement, cyan, being 180, and so on. Complement Cube constantly changes the colors displayed by slowly rotating the hues in the color wheel. Each side displays two complementary colors. We want to create a color relationship between the faces of the cube that is often referred to as triadic. That is, three colors that are equally spaced on the color wheel. If we add the second complementary color to the animation, it looks like this. Now let's see how it looks in action.
It certainly is weird out here. I've never seen anything like it before.
Like something out of a bad dream.
Come on over this way. Maybe they're in this direction.
Haven't we covered that area?
Not all of it. We came up from the other side of that cliff, but we didn't look down the bottom here.
Will Billy and Jane be off guard? What has happened to Tancho and Pat? We'll be back in a moment, so level up.
Look, there's another tunnel in the back. Duck after him.
I'm right behind you.
No, wait. Stand back. Look out, Pat. Pat, get down, quick.
Do you think something's happened?
Try to get him on the communicator.
Okay. Hello? Hello? Jane Darrow calling Planet Man. Jane Darrow calling Planet Man.
What's the matter? It's the kids. They may pick us up on the contactor, and we've got to get on board that ship somehow before they get wise.
We changed the frequency.
Sure, but they're pretty smart kids and may get the same idea.
Maybe they're in trouble. Maybe they need help.
Yes. And maybe those two, Slick and Blackie, are just waiting for us to stick our heads outside the ship. At least here we're safe, and we still can't be sure about the pirates, and this would be no time to bring them here.
Okay, let's go then if we're going.
I'll help you into your spacesuit, and then you can help me with mine.
Billy and Jane seem to be walking right into the trap set for them by Slick and Blackie. Will Billy and Jane be off guard? What has happened to Tancho and Pat?
Okay, now let's see how Complement Cube was constructed. Box design was done in Adobe Illustrator and saved as an SVG file. Besides the basic box outline, all holes for screws, knobs, and cable ties are included. Occasionally, I will use processing to create algorithmically generated SVG files through programming, but not on this project. The SVG file is then sent to my Glowforge laser cutter. I am using 1/4 inch and 1/8 inch acrylic that I have collected from scraps picked up at several local fabricators. Here's a look at the final cut pieces. Most of the box is black, but the bottom is red because I love this red acrylic and try to sneak it in wherever I can. The sides appear black, but the LED displays are covered by a 1/8 inch neutral density layer. I have some buttons on the back that let you choose various options. I also have a volume control knob and an on-off switch on the back. The larger rectangular hole allows a USB cable to supply power to the device. The device is held together with cable ties. I developed this system a while ago because I didn't want to use glue. I find it works quite well. Because of its form factor and performance, I chose to use the Adafruit Metro Mini version of the Arduino. I also like to use the Adafruit breadboards. They seem to be of high quality and look nice. I also like the standard breadboard style layout. I'm using the Adafruit NeoPixel 8x8 RGB LED matrix displays. The displays are embedded into a laser cut frame which is covered with neutral density acrylic. This is what the cube looks like without the covers on. And here's a look inside before the wires are attached. The bottom of the cube has rubber feet that create a space for sound to reach the microphone. I love the microphone. It's an Adafruit model with automatic gain control. When the location is quiet, it responds to the smallest sounds, but when things become loud, it adjusts to always keep the display active. A more questionable feature is the addition of a thermometer. The thermometer works fine, but because of all the LEDs, the cube becomes a bit warm. That throws off the temperature reading. I tried creating an airspace between the thermometer and the back, but it still needs work. The complement cube required quite a bit of programming. I had already constructed a similar device with a single LED panel, so I was able to modify some of the routines from it for use in complement cube. Since the NeoPixel library is designed to receive RGB color information, and most of the software I am writing uses the hue saturation brightness or HSB system, I needed to have conversion routines. Along with help from the internet, I got that going. I also needed to write routines that converted the sequential addressing of the NeoPixel LEDs to a more flexible system that let me address a specific LED by its panel number and the XY coordinate on that panel. Timing was a big part of the project. The program needed to walk and chew several pieces of gum at the same time. Each pattern required its own internal timing. Sometimes it's simple, other times more complex. The time each pattern should be shown needs to be regularly checked and updated. Since all the colors need to be constantly rotated around the color wheel, that needs to be timed and updated also. I have routines to display messages in ASCII text, convert colors to their complement or triadic values, read the buttons and switches and dials. The microphone needs to be constantly checked on, as is the thermometer. There are utility routines which determine the distance between LEDs for blending colors, convert array data into patterns, and many more. It's a good thing I generally enjoy writing code. Thanks for watching.